Here's my complete gray code to 7-segment hex project, which is done using Karnaugh mapping. Karnaugh mapping is a method used to simplify Boolean expressions by creating a truth table. To start, each segment on the 7-segment display is given its own truth table. Then, since the goal is to convert a gray code count, which looks like this, into their corresponding hex values, it first must be determined when each segment should be on or off for every number. For example, using the A segment, it is on for 0, off for 1, on for 2, all the way to F. After it is filled out, every number goes to its respective box in the K-map table. The columns are the leftmost digits and the rows are the rightmost digits. So 4 would go here because 0110 is gray code 4. For the next step, instead of 1s and 0s being rows and columns, they'll be replaced with letters, where A is the LSB and D is the MSB. A lowercase letter means a 0 and an uppercase letter means a 1. Now the K-map process can begin. It works by trying to find groups of 1s. The bigger the group, the simpler the function. Right off the bat, you can see a group of 4 1s in the middle. This can be represented by C ANDed with A. As shown, when A is high, all of these will be high, but if C also must be high, it only gives you the middle 4. To make things quicker, here are all of the possible shapes that can be identified with AND. This isn't every combination, but rather every shape. So C ANDed with not A has the same shape as A ANDed with not C. To go even further, there are a few AND functions that can be simplified if they both exist in the same table. For example, if both not A ANDed with not C and A ANDed with C both exist, they can be simplified to the function A XNOR C. And this makes sense, as XNOR is only high when both inputs are the same state. Here are all the XOR combinations. Note that XNOR would just be all the bits flipped. Going through every segment and trying to find the biggest possible groups, here are all the combinations that I found, trying to achieve the simplest terms. Finally, here's a false-state simulation of my gray code to hex display circuit. Note that in the actual build, I reused gates if possible, but did not for this simulation.